And here's a typical problem set from Alex regarding bonding polarity, bond polarity. And so as we look at some of these problems, we have to keep in mind the idea of electronegativity and know electronegative trends. And so let's look at this first compound right here, hydrogen bonding to chlorine. And it's asking us, is this red bond going to be polar or is it going to be nonpolar? Well, as we understand and know our electronegativities, we'll know that chlorine is a more electronegative atom than is hydrogen. And so in this case, this for sure is going to be a polar bond, and the more negative atom is going to be chlorine. Okay, let's look at the second one. We have bromine and fluorine. Okay, again, I have to understand and know about electronegativity in order to understand if this bond is going to be polar or not. So let's look at that periodic table and kind of refresh ourselves on trends. As we talked about in class, the most electronegative atom is going to be fluorine, and that trend tends to go this way. Okay, so as you go down, it is less electronegative, and as you go to the left, it is less electronegative as well. So fluorine is right here at the top right, and bromine is down 2 periods. And so we know that this is going to be a polar bond, and the more negative atom is going to be fluorine. Put that in there. Okay, let's look at that last one that we have here. We have bromine with bromine. So we have this bond that we're interested in here. Well, the bromine is going to pull equally on bromine. The electronegativities of each atom is the same, and that's going to result then in a non-polar bond. And so if I submit that to Alex, it should tell me that I'm correct on all 3 of those. Okay, let's just go to another type of problem that Alex is going to ask. Okay, it's saying to reorder each of these elements so that the elements are listed in order of decreasing electronegativity. That is, the first one in the list is going to be the most electronegative. So we have oxygen, fluorine, and sulfur. So let's just glance at that periodic table. Here's oxygen, here's fluorine, and here is sulfur. And so fluorine, if you remember our trends, is going to be the more electronegative. That should be first. Oxygen is right next to it. That will be second. And then as we move down a period, it'll be slightly less electronegative on the sulfur. And so my list should go F-O-S. So I go type that in, F, O, S. And that should give me a right answer. Okay, let's look at this next set. Selenium, tellurium, and sulfur. Okay, so here's the sulfur. Here's selenium down, so at least according to these two, then the sulfur is going to be first, then selenium, and then tellurium is right down here. And so we can see that our order should be sulfur, selenium, then tellurium. And so let me go ahead and type that in, S-E-T-E, and if I submit that, then I should get those right as well. Let's just go to a last set of problems that we have here, similar to that first one. Okay, let's look at these compounds right here. We have carbon dioxide, and the important thing to remember here is it's highlighting these red bonds right here. Okay, so the overall compound, carbon dioxide, is going to be nonpolar. However, it's asking about these bonds right here between the carbon and the oxygen. So they are going to have different electronegativities. Carbon is right here to the left of oxygen on the periodic table. And so this is going to be a polar bond. Okay, and that more electronegative, the more negative atom is going to be the oxygen in this case. Alright, we already had bromine and fluorine on the previous set, so let's just go ahead and fill that in, and fluorine is going to be the more negative atom. Okay, now we have nitrogen, okay, N2 floating around. And these bonds right here, as we've seen before, nitrogen is equally electronegative to the other nitrogen. Those are going to pull the electrons to each other equally, resulting in a very non-polar type of a bond. So if I submit that, then Alex should give me that I got that right. These problems are doable, shouldn't take you too long, and there's just a few examples of how to do them.